Greetings to all. Welcome back to the course on Introduction to Electric Vehicles. So in this video, we'll be learning about the motors which are popular in electric vehicles. So which are the motors popular in the electric vehicles? So the number one motors which you have already heard are PMSM motor, induction motor, and the PLDC motor. These three motors you must have heard whenever you have learned about the electric vehicle. So what is induction motor? So induction motors So the induction motor consists of a stator winding, rotor and the rotor cage. In most cases, we are using motor cage. Rotor can have two things, which is rotor can have a squirrel cage type rotor or it can be have a wound rotor type. The difference between wound rotor type and the squirrel cage rotor type is the squirrel cage is like this. It is shown like a cage of a bird. It seems like a cage of a bird, and this is the rotor core. So we are using a squirrel cage type rotor to depict the induction motor, but it could have been a wound rotor type. Okay, wound rotor means there are windings on the rotor also. On the stator, there are windings as we have learned in last video. It will be R phase, Y phase, and the B phase, and shifted by 120-degree electrical angle. Okay, so this is how the stator and rotor are placed. So what is the main fundamental of working? So in stator, the rotating magnetic field is generated due to interaction of these three waveforms or the R by B phase. Whenever the three phase is given, there is a rotating magnetic field in this. A north might be rotating like this and the south on the opposite side. So this rotation of magnetic field when cuts these conductors, these are the conductors. Okay. When this rotating magnetic field cuts these conductors, there is an induced EMF. Okay, and this induced EMF causes a current, circulating current in these, and the rotor itself generates its own EMF or its own MMF or the flux. So the chronology is like this. The flux of stator cuts the rotor and EMF in rotor is generated. This small r is for rotor, and the current in rotor is started to flow. This rotating current again generates the flux in rotor. So this generated flux, when interacts with the stator flux, it, due to the Lenz's law, it will try to it will try to oppose the cause, and in trying to oppose the cause, it will also rotate in the direction of the stator magnetic field, because the main purpose to oppose is to stop the stator from rotating, and if it cannot stop the stator magnetic field from rotating, it will rotate at the same speed at which the stator magnetic field is rotating. So if both the things are rotating at the same speed, there is no cutting of flux, but ultimately practically the rotor is not able to catch up the stator magnetic field speed, and due to this the rotor itself rotates at some speed smaller than the magnetic field speed. So if the stator magnetic field speed is ns and rotor magnetic field is nr, this is always less. Okay, this is always less than the stator magnetic field. So the main purpose is that is why the name induction motor is being given. So what are the benefit of induction motor? Induction motors are cheaper in construction cost, maintenance, and due to the no use of PM, these are very cheap and robust motors. Where these are being used? These are being used in Tesla Model 3 and Model S, BMW i3, Mercedes-Benz B-Class. These are all the vehicles, EV vehicles, which are using our induction motors. Second is the permanent magnet synchronous motor. So the permanent magnet synchronous motor also works on the similar principle, except the difference is here we do not need an induced EMF or the induced magnetic field. Here we are putting the magnets. So these are north-south magnet we are putting here, and the stator, again there is a rotating magnetic field, and as the rotating magnetic field is rotating, it will couple the south pole, the north pole on the stator which is rotating will couple the south pole on the rotor, and they both, once the magnetic coupling is done, they both will be rotating at a similar speed. So here in this case, the speed of stator magnetic field is equal to the rotor field, and both are rotating at a synchronous speed. That is why the name synchronous is given to the motor. So this is due to the interaction between the stator magnetic field and the rotor magnetic field. This PMSM can also are also of two types, and that two types is also defined by the rotor. If the magnet is buried inside the rotor, like in this case, This will be known as the interior permanent magnet synchronous motor. Interior means the magnet is buried inside the rotor. And second is the surface mounted. If the magnets are kept on the surface here, then it is known as the surface mounted PMSM motor, okay, or the SPMSM simply. What are the benefits of PMSM? PMSM, the major benefit is the high efficiency, high torque density, high power density, and this is due to the use of magnets. Because you are using the magnets, the efficiency goes up, and also the torque density. The same, if a 20 Newton meter can be generated by this much big induction motor, then the similar torque can be generated by almost of a half size of PMSM motor. That is why these motors are being popularly used in the electric vehicles. And these are being used in Ford, Focus, Hyundai, Ioniq, Tata Nexon is also using the PMSM motor. And this is one of the major motor which are being used in the high performance electric vehicles. And the third motor, which is the BLDC motor, it is similar to the DC motor, but this is electronically commutated. What is the commutation? Commutation is a process of converting, switching the current from one coil to second coil. This switching of current in actual, the real DC motor, which are the brush DC motor, was done using the commutator and the brush set. But here electronically commutation can be done, or in simple term we can say that we'll be switching the, here you can see that we are switching the coils, and the rotor consists of a north and south pole, simple, and whenever the coil is, whichever the coil is switched, the rotor is rotating in that direction. When this coil is switched off, then the next coil is switched on. So wherever the flux is generated, the rotor will be shifted to that coil. So this is simple method of switching. So this is known as electronic commutation of DC motor. Okay, these motor are very popular, but these have a efficiency lower than the PMSM motor. These are one kind of the PM motors, but their efficiency is less than the usual PMSM motor. These are easily manufactured and readily available. So this kind of BLDC motor can be of two types: inner rotor, where the rotor is inside as shown in this figure, and outer rotor, where the rotor, this is stator and the rotor is outside. These are also known as hub motor, where you can see that the tire of a scooty is itself a motor, where the stator is in the center and the outside part is a tire. So this outer rotor BLDC is especially used in our e-rickshaw or in case of the two-wheeler. So BLDC is excessively used in two places, which is two-wheeler and three-wheeler. Three-wheelers means e-rickshaw. So this e-rickshaw uses, and sometimes drone or two-wheeler I've already told. So these are the places where the BLDC is being used. Why these are used? Because of the easily manufacturing capability, and these are readily available in market at a very cheap cost. So these are the reason why it is being used in two-wheeler or the three-wheeler. So this is all for this video. We'll be learning about some of the future motors in the next video. So thank you all. Thank you.